Good afternoon, dear students. Hope doing well. Today we are going to continue what where we have reached in the last lecture before uh, started coronavirus. Um, First of all, hope doing well and stay safe. So today we are going to finish our chapter CPU scheduling. As you know, we have finished the mathematic stuff, and the remaining from this chapter, the theory part. So I'm going to attach for you in the portal two files, one regarding the CPU scheduling, and once we finish the theory part from this chapter, we're going to go to the memory management chapter. Both of them, it will be in the PDF format, okay? Plus, in case if you have a question, send me a message on the portal. So first of all, we are going to talk about the theory part in the CPU scheduling. So here we have some explanation, some questions that we have to note. So here we start with the first question. Says what are the optimization criteria? So as you know, in the scheduling we have some criteria that we have to set it out to optimize our scheduling. So first of all, we are maximize CPU utilization, and we have max little throughput and minimum little turnaround time and minimum little waiting time and minimum little response time. So those 5 points are what optimization criteria for the CPU scheduling. Okay, so first of all, uh, we need to maximize our CPU utilization, and number two, we want, so here number one, we want to maximize our CPU utilization. Number two, we want to maximize our throughput, means how much we are going to achieve in a particular time, and we want to minimize turnaround time and also the waiting time, how much the process waiting, we want to minimize it. And plus also we want to minimize what a response time, yani between sending the request, how much time between sending the request and the response come back. So come to the next part, which is here. So we have a question says what we mean by CPU scheduler and when the CPU take a decision. So here the first point, we are talk about what we mean by CPU scheduler. So means CPU scheduler, is selecting, or the process of selecting from among the processes in the main memory that are what ready to execute, and allocate the CPU to one of them. Means the CPU scheduler is going to select from all the processes which are in the ready queue, which are ready to be executed. Yeah, they are in the ready state. The process, if it is in the ready state, so the CPU scheduler is going to select them, and they will give them the CPU to start execute. Now, number two, he said what? He said CPU scheduling decision may take place when. Okay, so when the CPU scheduling, he will take a decision. When a process what? When the process, it is switching from running to waiting, or running to ready, or from waiting to ready, or it is what? Finished, terminate, exit. So if the process in those states, the CPU he will take a decision. Okay, the CPU take a decision. So now when it will take decision, we have two cases. As you remember in the mathematics, we said the scheduling either it is preemptive or non-preemptive. So what he said? He said if the process it is in one of those states, we call it what? We call it non-preemptive, which is here. He said what? Scheduling under 1 and 4, sorry, the scheduling under 1 and 4, it's non-preemptive. So just to clarify it, it's um, uh, misunderstanding. So here 1 and 4, it is what? It is non-preemptive. Non-preemptive, which means when the process allocate the CPU, it will not release the CPU until unless it will what? Finish. يعني the process gets 0. يعني the first time it will be finished. But when other stages or other cases, because here we have 4 cases, 1, 2, 3, 4. If the process it is switching from running to waiting, or if the process it is terminate, so this we call what? Non-preemptive. Except of that اللي هو case 2, case 3, both of them are what? Are what? Preemptive. Preemptive means what? Means if we are doing, for example, priority scheduling preemptive, if the running process priority lower than coming process priority, we are going to do what? Swap. Yani we are going to switch between them. Okay. So this is regarding the what we mean by CPU scheduler and when the CPU take a decision. In those 4 cases, we are going to do this, take a decision. Case 1, case 1, case 4, case 1, case 4 are what? Are non-preemptive. Case 2 and 3 are what? Preemptive. Okay, so now we will remove all this. Now we will come to the next question. So here we have a question. He says what we mean by dispatcher and dispatch latency. Dispatcher latency or dispatch latency. So the question, what do you mean by dispatcher and what do you mean by dispatch latency? So dispatcher means it's a module, okay? He will give control of the CPU to the process that's selected by what? Short-term scheduler. As you remember, we said before, short-term scheduler, long-term scheduler. So dispatcher, it is what? A dispatcher, it is a module give control of the CPU to the processes that are selected by whom? By the short-term scheduler. Okay, so this what it include? So it include or involve switching context, okay, switching to user mode and jumping to the proper location in the user program. Okay, so here this is all talk about what? About dispatcher. The next thing that we have to know is dispatch latency. So dispatch latency, when we talk about latency, means we are talk about time. We are talk about time. So dispatch latency means it is what time it take for the dispatcher to stop one process and what start another one. So the time between stopping one process and start another one, we call it what? We call it the dispatch latency. Okay, this is very important. Now, The next thing, or the last question here we have in this chapter, we are talk about the scheduling criteria. What are the scheduling criteria? So when we talk about in the CPU scheduling chapter, we talk about scheduling criteria and how we are going to optimize those criteria. So first, the scheduling criteria, first, it is what? It is 5 points or 5 criteria. Number 1, CPU scheduling. Number 2, throughput. Number 2, turnaround time. Number 3, turnaround time. Number 4, waiting time. Number 5 is response time. So we have 1, 2, 3, 4, and 5. So first, what is utilization? Utilization means we have to keep our CPU busy as much as possible. We don't want the CPU idle, yani free. We want to make it busy. So number 2, as a criteria, we have what? Throughput. Throughput means how much we are done in a particular time. So you say what? Number of processes that complete their execution per time. So how much processes finished in a fixed amount of time. This is called throughput. A turnaround time, amount of time to execute a particular process. How much time to execute a particular process or to finish a job? How much time? Waiting time means amount of time a process have been waiting, has been waiting in the ready queue. يعني how much time the process is waiting in the queue, we call waiting time. A response time means amount of time it take from when a request was submitted until the first response is what? Produced. Okay, so response time means when we are going to send, how much time between sending the request and getting the response back. How much time between sending the request and the response, the first response come back. This time, how much time, how much second, those we call response time. So up to here, we are finishing chapter CPU scheduling. Okay, and next I'm going to talk about the memory management. Okay, students. So in case if you have any question, kindly please send me a message on the portal, and I will try as soon as possible. Once I saw your message or your question, I will reply to you and clarify any doubt if you have. I'm going to record this lecture on my channel on YouTube. Plus also I'm going to send you the link on the portal. Plus I will send you the PDF file of this lecture plus the next lecture. Hopefully you'll be well and stay safe. See you soon, inshallah. Goodbye.